Hello everyone, welcome to Equal To, and this is the 6th episode of the number systems playlist. So if you haven't watched the previous 5 videos yet, I'll give you a link, you can go and check that out. Now, in the previous video, we solved exercise 1.2, all problems of that, we have solved it. And in that, the last question was representing root 5 on a number line. So that is it with the last exercise. Now, moving on, we are getting into something new and we are going to start with a few examples. Okay, now here we have example 5 of this chapter, which is find the decimal expansions of 10 by 3, 7 by 8 and 1 by 7. Okay, now there is something that we are going to learn at the end of this example, so please wait for that. Now first we are going to find the decimal expressions of this fractional numbers. Okay, that is what we are going to do now. Now let me just take this first number. So what is the first number? It is 10 divided by 3, right? So 10 divided by 3. So 3 times 3 is 9, right? So this is a very common division that we have been doing for years. There is nothing innovative here. It's just the same one. So you can just follow along. Okay. Now 3 times 3 is 9 and that would give you a remainder of 1. Okay. Now 3 is not divisible in 1. Okay, so what you're going to do is that you're going to place a dot here, place a point, and you're going to add 0 here, right? Very easy. This is what we have been doing for years. Okay, nothing new here. Okay, now we have 10 again, and that would again bring us 3 in the quotient, because 3 times 3 is 9. So that would have 9 here, and again you are getting a remainder 1. Okay, now we are going to repeat this again and again. So what would be the quotient? The quotient would be 3.33333 and it repeats forever. No matter how many times you perform the same things, it is going to give you 3 again and again and again. Okay, so the answer would be 3.333333. Now, there is another way to represent this easily for these kind of repeating things. That is, this is how we represent that. I'm sorry if you hear any traffic noise. I'm trying to record in noisy environment, so please don't mind. Sorry if it wasn't good. Okay, now we have 3.3 bar. This is what we call as bar. It is a line above here, right? I have drawn a line over 3. Now we had so many 3's, but I have written 1 3 and drawn a line over it, meaning that repeats forever. It is going to recur again and again and again. Okay, so 3.3 bar. So this is the decimal expansion for 10 divided by 3. Okay, this is one thing that we have. Okay, now let us keep this aside and move on to the next fraction that we have, which is 7 divided by 8. Okay, 7 divided by 8. Now 7 is smaller than 8. Okay, no matter how many of 8 you take, that will not go in 7. 7 is smaller than 8. So what you do is you place a 0 here and a dot and you make this 70. Okay, now there is nothing innovative here, there is nothing new to learn here. This is a very basic division that we have been doing for years. Okay, so I hope it is not a problem for you. So we are placing a 0 in front in the quotient and a dot, and we are making it 70, and we know that 8 times 8 is 64. Okay, so the quotient here would be 8 and that would give you 64, and that would give us a remainder 6. Okay, now again 6 wouldn't go, so you take a 0. So how many times of 8 will go in 60? 7, right? 8 times 7 is, what is it? 7 times 7 is 49. 7 times 8 is 56, right? 8 times 7 is 56. So that would give you a remainder 4. And again the 0 comes down, and 8 times 5 gives you 40. and that gives you a 0 remainder, and that is the end of it. Okay, so the decimal expansion for 7 divided by 8 is 0.875. so this is the decimal expansion for 7 by 8, 0.875. Now we'll keep this aside. So this has an ending. Okay, in the previous example we saw it was 3.3333, it goes on, and that we represented as 3.3 bar. But in this example it has only 3 decimal points and it has ended. 0.875 is the value. Now we are moving to the third fraction. Okay, the third fraction that we have here is 1 divided by 7. 1 divided by 7. Now obviously you cannot, there is no way, like any natural numbers multiple of 7 wouldn't go in 1. Okay, now don't think that I'm using fancy words, these are just simple words. Let me just not complicate this. Okay, so 1 wouldn't go. Okay, so what would you do? You would add 0 in the quotient, you would have a point, and that would give you 10. Okay, now 7 times 1 is 7, and that would give you a remainder 3. Okay, now we have a 0, so 3 0. Now 7 times 4 is 28, and that would give you a remainder 2. We again have a 0, and 7 times 2 is 14, and that would give you a remainder 6. Okay, we add a 0. 7 times 8. 7 times 8 is 56, right? And that would give you a remainder 0. Sorry, that would give you a remainder 4. And again you have a 0. 7 times 5 is 35, and that would give you a remainder 5. Okay, and again a 0, and 7 times 7 is 49, and that would give you a remainder 1. Now when it comes to 1, you are going to do it again. You add a 0, 7 times 1 is 7, and that gives you a remainder 3. Now doesn't this look a little familiar? Now if you again add a 0, it would be 7 times 4, which would be 28, and would get a remainder 2. Now what you can observe is that we have a number 0.142857, and this number keeps on repeating. So how do we represent such a number? With a bar up top. Okay, so 0.142857 bar. Okay, now that is the decimal expansion for this entire block 142857. This keeps on repeating. Okay, now that is how we represent the decimal expansions of 10 by 3, 7 by 8 and 1 by 7. Now here the first one is non-terminating. Okay, why am I telling it is non-terminating? Because it is 3.33333, it goes on forever, it never stops, it never terminates. So that is something that we call as non-terminating but repeating. Okay, non-terminating but it is repeating. Now the second case that we have here is, let me just highlight this. Okay, this is important. The second thing that we have is terminating. Now it has a definite ending. It only has 3 decimal places and it has a definite ending. It is not repeating and also it has an end. Okay, so it's a terminating. And the last one is also non-terminating. Non-terminating, and also as we saw, it is repeating. Okay, I hope you understood what we are talking about. Now we had three cases. The first one is non-terminating and repeating 3.3 bar. The second one was terminating 0.875, and the third one was also non-terminating but repeating, which is 0.142857 bar. So the entire section is going to repeat. Okay, now what they are telling is that basically the questions, like the three numbers here, 10 by 3, 7 by 8 and 1 by 7, these three are rational numbers, right? These three are rational numbers. We know that. Now what they are trying to tell is that if you express a rational number in decimal form, it would either be terminating or non-terminating but repeating. This is case 1. Okay, case 1 is non-terminating but repeating. Case 2 is terminating. So there is only two things that is possible with a rational number when it is expressed as decimals. Okay, it can either terminate or it cannot terminate but repeat itself. Okay, so these are two things possible. That is all for this example 5. Now we are moving to the next example. Okay, and it's quite different to the first one. Now I hope you understood the example 5 here. It's very important for you to know that rational numbers can either be terminating or non-terminating but repeating. Okay, and if you are given a rational number, you should be able to express it in decimal form. Okay, that is it. Now moving on, we have example 6. Okay, now what is this question? We are given that show that 3.142678 is a rational numbers. It's a rational number. In other words, express 3.142678 in the form of p divided by q, where p and q are integers and q not equal to 0. Okay, now this is just the definition of rational numbers. Okay, they are just repeating themselves to make you understand it clear. Okay, so what they are given is that they are given you a number which is 3.142678. Okay, now this is a number that they have given, and you are supposed to prove that this number is in fact rational. So how do we prove that it is rational? It should be expressed in the form of p divided by q, where p and q are integers and q not equal to 0. Okay, now if we are supposed to express this in the form of p divided by q and p and q not be p and q be integers, so how do we convert this into an integer? Okay, now integers are numbers without fractional part, right? Integers are number without fractional part. So to convert this into an integer, you need to remove all these decimal places, right? It has how many decimal places? It has 1, 2, 3, 4, 5, 6 decimal places. We have to remove that to convert it into an integer, and only then it would be in the form of p by q, where p and q are integers, right? So how do we do that? 3.142678, and you know that to convert it, it has 6 decimal places, so you should multiply it with a number where it is 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. So these are zeros. Okay, now only when you are multiplying with this number, it would get converted into an integer. Now since you cannot just multiply the numerator, okay, now that would entirely change the value. So how would you do that? You multiply the denominator by the same number, 1, 2, 3, 4, 5, 6. Okay, not 6, 6th 0. Okay, now since both these numbers are just same, their value is essentially 1. So any number multiplied with 1 would give you the same number. So it is not a problem for you to multiply 3.142676 by what number is this actually? It's 10 lakhs, right? I hope it is 10 lakhs. Okay, so it is not a problem for you to multiply with this, and that is not going to change the value of this number. Okay, now what happens when you multiply by this? That would give you 314 0.2676 divided by 1 followed by 6 zeros. 10 lakh. Okay, now we have this number which is the exact same value of the number given in the question. It is the exact same value. Okay, now is this a rational number? Is this of the form rational number? Obviously yes. P and Q are in fact integers. P and Q are integers. The above value 3142676 is also an integer. 10 lakh below the denominator is also an integer, and obviously 10 lakh is not equal to 0. So numerator and denominator are integers and denominator is not equal to 0, meaning this is a rational number and it can be expressed in the form of P by Q where Q not equal to 0. Okay, I hope you understood this. This is a very simple question. You are supposed to show that 3.142678 is a rational number and you have just multiplied it by 10 lakh divided by 10 lakh and it's essentially 1. Okay, that would give you 3142676 divided by 10 lakhs, and that is in the form of P divided by Q where Q not equal to 0, and that is the end of this example. Okay, I hope you got this. Now we are moving to the third example, and this is where it gets quite interesting. Okay, now you have to observe this very carefully. We are going to do a maths wizardry. Okay, so that is what you are going to do now. Now let me just read the question first. You are supposed to show that 0.3333, which is essentially 0.3 bar. We just saw it in the first question of this video, example 5. So 0.3 bar, it can be expressed in the form of P divided by Q where P and Q are integers and Q not equal to 0. So what they are trying to tell is that basically show that 0.3 bar is a rational number. That is your question. You are supposed to show that 0.3 bar is a rational number. How exactly are we going to do that? Just follow me carefully. Watch what I am writing and observe it. Okay, don't worry about things. Just observe it. I will explain it once again for you to make things very clear. Just follow me now. Okay, now what you are going to do is that you are going to say let x is equal to 0.3333 and so on. Okay, you are going to assume that x is equal to 0.3333. Okay, and let me consider this as equation 1. Okay, we have assumed x is equal to 0.333. Now in this case we know that only one digit, that is 3, that is the only digit that keeps on repeating, right? Am I right? Only one digit, that is 3, that keeps on repeating. Now since it is only one digit, what you are going to do is that you are going to multiply this equation 1 by 10. Okay, multiply equation 1 by 10 on both sides. Obviously multiplying it only one side, that would make it an inequation. It wouldn't be equal to the LHS wouldn't be equal to RHS at that point. So we are going to multiply by 10 on both sides. So what would that give you? It would give you 10x is equal to 3.333333. Okay, you would get this. Now let us assume this as equation 2. Okay, now this is equation 2. We have two equations now. What I am going to do is that I am just going to rewrite this equation 2. 10x is equal to 3 plus 0.3333. Okay, now what have I done here? I have just split 3.33 into 3 and 0.33. Now when adding these two things, it would obviously give you expression 2, equation 2, right? So I am just splitting it up. Okay, now 10x is equal to 3 plus 0.333. Now from equation 1 we know that 0.33333 is in fact x. Okay, that is equation 1, right? Now in all these lines 0.333, the 3 never ends, it keeps on going forever. Okay, so x is equal to 0.3333 forever, and in the final equation that we have, 10x is equal to 3 plus 0.333. Now, we know that this particular portion is in fact the value that we have assumed, which is x. Okay, so we are going to substitute that here. Substitute equation 1 here. If you do that, what would you get? 10x is equal to 3 plus x. Am I right? 0.333, that has been replaced with x. Okay, because that is the assumption that we started with. Now, this is a linear equation that you have. You can easily solve it. Let us subtract x on both sides. Okay, minus x, or just for simplicity, or what you have already learnt is taking this x to your LHS, and that doesn't really happen in maths, right? You are actually subtracting x on both sides, and if you subtract x on both sides, on the LHS you would get 9x, and on the RHS you would just have 3, right? Because this x and this x gets cancelled. I think I'm better off using a different color. This x and this x get cancelled, and this 10x becomes 9x. Okay, so 9x is equal to 3. That would tell that x is equal to 3 divided by 9, which can be simplified into 1 by 3. Okay, and that is the value of x. X is equal to 1 by 3. We have found this. Now, is 1 by 3 a rational number? Is 1 by 3 a rational number? Obviously, it can be expressed in the form p by q, where q not equal to 0. Now, in this case, this is p, this is q. Okay, both these are integers and q is not equal to 0. And hence, 0.3 bar or 0.333 forever is a rational number which can be expressed in the form of p divided by q, where p and q are integers. Okay, now if you haven't understood this clearly yet, I am just going to tell you once again, just bear with me. Now we are supposed to prove that 0.3 bar is in fact a rational number, and that is of the form p by q, where p and q are integers and q not equal to 0. Now what we have done is that we have started with an assumption that x is equal to 0.333. Okay, that is an assumption. Now what you are going to do is that we are going to observe how many digits are in fact repeating in the question. We notice that only 3 is repeating. It's the only one digit that is repeating. Now since it's the only one digit, we are multiplying this equation by 10 on both sides. You are taking equation 1 and multiplying it by 10 on both sides, and that gives you 10x is equal to 3.333. Okay, you get that. Now I am just going to rewrite this expression in the form that 10x is equal to 3 plus 0.333. Since we know 0.333 is the value of x that we assumed, we are just going to replace this with x. Okay, substituting the equation 1 here. Now that would give you 10x is equal to 3 plus x, and that you can simplify to 9x is equal to 3. That leads us to the value x is equal to 1 by 3, and this is a very simple thing. Okay, now you can go through this once again, pause the video, go through this once again. It's very simple, but this concept would be used to solve furthermore problems in the next video. So please stay tuned for that. The next video is coming tomorrow. Thank you so much for watching this one. If you have any questions, any doubts in the problems that we have seen today, please post them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this one. See you in the next video. Bye for now.